Students, Mrs. Keller here with another video for you, this time graphing the transformed sine and cosine functions. You're going to want to make sure that you are really feeling familiar with how to graph the regular sine and cosine function before we start adding in more complicated transformations. So if you need to go back and rewatch those videos, I would encourage you to do that. Here we are, just a quick refresher about the regular sine function without any transformations. It will start here at the origin, and it will start and end on the midline. And the midline, without any transformations, is just this x or theta axis. Halfway between, it will cross the midline. Halfway between the first 2 points, it will reach its maximum. And halfway between the last 2 points, it reaches its minimum. And so that pattern kind of continues on and on from negative infinity to infinity. Now let's look at a transformed function. So this function here, y equals the sine of theta plus 2. If you recall from our transformations video, this is going to shift our graph up 2 units. So our amplitude is still going to be 1 unit because nothing has changed there. The period length is still going to be 2 pi, nothing has changed there. Our only change is up 2 units. Now for this graph, it might just be easiest to just shift every single one of these points up exactly 2 units. And that's fine if you want to do it that way. When we start adding more difficult transformations, that's not probably going to be the best or easiest method. So let me show you the way that I like to graph these functions. I'm going to draw 3 horizontal lines that are going to kind of act as guideposts for me. So I want to draw the midline, I want to draw the maximum, and I want to draw the minimum. So because this graph has been shifted up 2 units, the midline is no longer at y equals 0, but it's going to be up here at y equals 2. So I'm going to sketch in a dotted line just to be a reference for myself. Now the amplitude is 1 unit, which means that I'm going to go from this midline, the maximum will be 1 unit above, so that'll be up here at y equals 3. The minimum will be 1 unit below that midline at y equals 1. So I now have these 3 dotted lines to act as a guide for me to know exactly where to graph my function. My entire function is going to fit within this range from 1 to 3. So since there aren't any other transformations, I know that my graph is going to start here at 0 on the midline. I used a little star here just to kind of show you exactly where I'm starting the function. And now the period length is 2 pi, so I'm going to go 2 pi away and graph another point on the midline. Play that game of halves that we've been talking about. Halfway in between for sine, we cross the midline again. Halfway between the first 2, we reach up to the maximum. Halfway between the last 2, we reach down to the minimum. And having those nice dotted lines will help us make sure that we graph our function exactly in the right spot. And then basically you're just going to follow that same exact pattern in the other direction. So you can see here, the red graph was our basic sine function. The purple graph is just shifted up 2 units. Let's try one a little more difficult. So this function now has a couple other transformations. Our amplitude has changed. It is now 2 units because of this a value in front. The period length is still 2 pi because I don't have any b value changing that. And now we've shifted the graph left pi over 4. Same thing, we're going to start with those 3 horizontal lines. So because we've not shifted up or down, our midline is going to stay right here on that x or theta axis. The amplitude is 2, so my maximum is going to be up here at y equals 2, and my minimum is going to be at y equals negative 2. So I have those guidelines to help me know exactly where my midline, max, and min are. Now I would normally start the sine function on the midline at 0, but this time I've shifted to the left pi over 4, so I'm going to just start right here at negative pi over 4. The period length is 2 pi, so I'm going to go 2 pi units away from that starting value, which is 7 pi over 4. And then we're just going to play the game of halves again. Find exactly halfway in between those, which is 3 pi over 4, and that's on the midline as well. Halfway between the first 2 points, we reach up to our maximum. Now you might be tempted to graph it here at 1, but recall our amplitude is 2, so we're going to reach all the way up here to our maximum up on our dotted line. And then halfway between these last two, we'll reach down to our minimum here. And then we will sketch that curve. So there's one cycle of the sine function. And we'll just basically do the same thing in the opposite direction. I had to go a little bit off my graph paper to make 2 complete cycles fit. So you can see here that the graph has been shifted to the left pi over 4, and then it's also been stretched vertically. Let's try cosine function. If you recall, the basic cosine function starts and ends at the maximum, and then halfway between it reaches its minimum. Halfway between the first two crosses the midline. Halfway between the last two crosses the midline. It's important for you to remember the difference between sine and cosine and pay careful attention when you go to graph so that you know which one you're starting from. So here, let's find our transformations. We have an amplitude of 1 because there's no a value in front of the cosine other than just 1. Our b value is 2, which means the period is going to be 2 pi divided by 2, or pi. Our h is here, and so we've shifted to the right, pi over 2. And our k is here, so we're shifting down 1. I'm going to start by sketching those 3 horizontal lines again. So I've shifted down 1, which means the midline is now at y equals -1. That midline is always at y equals k. The amplitude is 1, so that means my maximum is going to be right here at y equals 0, minimum at y equals -2. Normally, cosine would start at 0, maximum. We are shifting to the right, pi over 2, so I'm going to come over here, and I'm going to start right there at my star. So I'm going to start here at pi over 2 at the maximum, and then I'm going to go 1 pi away, and I'm going to be at the maximum again, because cosine starts and ends at the maximum, and the period length was pi, so I go exactly pi away. Play the game of halves, halfway between, minimum, halfway between, cross the midline, halfway between, cross the midline, sketch that curve, and do the same thing going in the other direction. There are 2 cycles of cosine. Now, you don't always have to sketch the original cosine first and then try to figure it out. Let's just look at one where we're just going to look, oh boy, we've got a whole lot going on in this graph. We've got a negative value and fractions and all sorts of things. So first thing we would want to do is find all of the information we need to help us graph. Our amplitude is 3/2. The period length is 2 pi. It does have a vertical reflection because of that negative. We're shifting left pi over 4 and up 1/2. So that midline is going to be here at y equals 1/2. And the amplitude is 3/2, so 1.5. So that means the maximum's up here at 2, and the minimum is at -1. Once we sketch those in, we are ready to start. Cosine normally would start at 0 and the maximum, but we are reflected, so we are going to start at the minimum, and we're shifted left pi over 4. So basically, we are starting here. Then what we're going to do is we're going to go 2 pi away, right here. And we're going to be at our minimum again because of that reflection. Halfway in between, we're going to be all the way up at the maximum. Halfway between those, we will cross the midline. And halfway between those two, cross the midline, sketch that cosine. Follow that pattern. You can think about it. Once you've graphed one complete cycle, you can just follow the pattern. So we went right to midline, right to maximum, right to midline, right to minimum. So we can kind of continue the pattern along this way for the other half. Right, left 2 up to the midline, left 2 to the max, left 2 to the midline, left 2 to the min. And so you can kind of, once you've graphed one cycle, just follow that pattern to help you finish completing another cycle of the graph, because I always want you to graph 2 complete cycles. All right, so I hope that this video has helped you with figuring out how to graph the sine and cosine transformed functions. If you have any questions at all, please, please, please reach out to me. I'd be happy to help you. That's what I'm here for. I hope you're doing well, and see you in the next video.